All right, let's jump right in. We've all seen Roman numerals, right? But have you ever really stopped to think about the simple, elegant logic that makes them work? Today, we're going to crack the code on a classic programming puzzle that turns this ancient system into a really simple set of rules.
It really all boils down to this one central question. How come VI is 6, but when you flip those exact same letters around to IV, suddenly it's 4? One moment you're adding, the next you're subtracting. What's up with that? This is the puzzle we're going to solve. And this just lays it out perfectly. On the left, with V, the logic is super simple addition. 5 plus 1 equals 6. Easy. But on the right, with IV, the whole game changes. Now it's 5 minus 1, which equals 4. So how does a computer, or even our own brain, know when to switch between these two rules?
So let's just call this what it is. This isn't just about memorizing letters. It's a full-on logic puzzle. And like any good puzzle, it has a surprisingly simple key once you finally see it. And that's the crucial point. Look, we all know V is 5 and I is 1. That's the easy part. The real trick, the core of the problem, is figuring out that hidden rule that tells you when to use a plus sign and when to use a minus sign. So, are you ready for the secret, the aha moment? Well, it turns out the solution is beautifully simple, and it's all about reading from left to right and thinking just one step ahead. And there it is, the entire solution in one sentence. The key isn't the character you're currently looking at. Nope, it's the one that comes next. Just peeking one step ahead tells you everything you need to know. Okay, so that's a great little secret, but how do we turn that into an actual process? Let's break down the logic into 4 clear, simple steps that any computer program could follow. Here's our roadmap. First, we need a reference guide, a cheat sheet for the values. Second, we need a place to keep score. Third, we apply our peek ahead rule over and over again. And finally, we just have to take care of that very last number. Let's walk through it. First things first, we've got to teach the program what each letter means. A lookup table, or what coders might call a dictionary, is perfect for this. It's just a simple reference that instantly connects each character to its number value. Next up, step 2. We create a scoreboard. We'll call it our results variable and just set it to 0 to start. As we go through the numeral, we'll either add to or subtract from this total, building up our final answer. And here we are, the engine of our entire solution. This one simple rule handles every single case. As we read from left to right, we just ask, is the number I'm on smaller than the number right after it? If the answer is yes, we subtract. For every other situation, we just add. That's it. Okay, let's put this rule to the test with our original puzzle, IV. Remember, our total starts at 0. Let's look at that first character. We start with the I, which our table tells us is worth 1. But hold on, before we do anything with that 1, it's time to apply our secret rule. And that means we peek ahead. The next character is V, which has a value of 5. Okay, perfect. Now we have the 2 pieces of information we need to make our decision. So we ask our question, is the current value, 1, less than the next value, 5? Well, the answer is a clear yes, and that triggers the special subtraction case. Because the rule was triggered, we take the current value of 1 and subtract it from our running total. Our score, which started at 0, is now -1. I know, it feels a little weird, but trust the process. Now, our little process is designed to stop just before the last character. Why? Well, think about it. The last character can never be subtractive. There's nothing after it to compare it to, so it is always added to the total. And this is where it all comes together. We take our running total, which was -1, and we add the value of that final character, V, which is 5. And what's -1 plus 5? It's 4. The logic works perfectly. So let's zoom out for a second. What's the big picture here? Why is this simple solution so effective and, frankly, so cool? This logic is powerful because it's just so elegant. It takes what seems like a complex problem with a bunch of exceptions and boils it all down to a single, repeatable question. This sequential, look one step ahead approach isn't just for Roman numerals. It's a fundamental pattern used to solve all sorts of complex problems in coding and beyond. And that leaves us with a final thought. This pattern of making a decision based on what's coming next is incredibly versatile. You see it in everything from checking grammar in a sentence to navigating a maze. So the question is, what puzzle in your life could be cracked by just peeking around the next corner?